This is section 3.3, increasing and decreasing functions, and also average rate of change. So we will first start with increasing and decreasing functions. So here I have a graph of a curve, and it shows points A, B, C, and D, and the values of x at each of the point are represented by lowercase a, lowercase b, lowercase c, and lowercase d. The y values would be whatever over here, and we aren't labeling those because when we are talking about the increasing and decreasing intervals or areas or parts of a curve, we are always referring to those in respect to the x value. So A, B, and C, and D all represent the x values, the values of x for the points A, B, C, and D. And we would say that the graph above is increasing, okay, from the intervals from A to B. So interval A to B in its brackets, and then also from C to D, and that is also brackets. So we are increasing from in those intervals. So A to B going from lowercase a to B, and then lowercase c to D. So visually, you can obviously see going from left to right, you're going uphill. The graph is decreasing at the interval between B and C. Okay, it's going downhill, and again, brackets. So you can use a bracket to start from B to C because you can include the point. It is a starting point. You don't need to use parentheses or anything like that. All right, so our interval of increasing and decreasing is just simply looking at the graph and being able to identify the values of x from which you start and finish your increasing, or start and finish your decreasing. So remember, interval notation refers to the values of x only. Sorry, that was a really bad line. Interval notation refers to the values of x only. When we talk about average rate of change, we know that average rate of change is basically the same understanding of slope for lines, but here we are working with curves. So I'm giving you this curve down here where I have the first point a comma f of a. Remember, in just like above, my lowercase a is your value of x, and my y is the function evaluated at a. So I have to remember that notation. Whenever you have f of a or f of b, that's representing the y value. So we know slope as y2 minus y1 over x2 minus x1. So if I think about this a here as x1, and f of a is y1, and b is x2, and f of b is y2, then I could think about the same formula from slope and convert it to function format for average rate of change. So y2, which is your f of b, minus y1, which is your f of a, over your x2, which is b, minus your x1, which is a. So function format for average rate of change, because we are working with curves and not lines, it is written in function format. So f of b minus f of a over b minus a. But you and I and everyone else would also be thinking about this as y2 minus y1 over x2 minus x1 if we are talking about looking at a graph. In an example that we will be doing, it is written in, we are given a function and we are given specific values to evaluate the function, and we have to have that understanding of what do these values mean and what we do when we plug them in and evaluate. Okay, so the function format is really not any different than finding slope. Okay, all right, so let's look at some examples. This first example says determine the intervals on which the function is increasing and which it is decreasing. Remember, intervals are your values of x, okay? And we are looking for the values of x for which it is increasing and then decreasing. So increasing, we want to look from left to right. Where is it going uphill? So this first little curve here, going from left to right, we hit that first little curve, which is going downhill. And then we hit this middle curve, which is going uphill. Okay, so that's increasing. So where does it start increasing? It starts increasing at -1. Where does it finish increasing? It finishes increasing at +1. Now this is a solid dot and a solid dot, so I'm going to go ahead and use the notation for solid dots, which is brackets. So we are increasing from -1 to +1. And if I look at the third curve, that is going downhill. So the other parts of this graph are decreasing. So again, I want to identify going from left to right, where is my graph going downhill? So going downhill, starting here at -2 and stopping at positive or -1. So I'm going from -2 to -1. Now, I'm not really actually positive if it really truly matters, but we'll go ahead and stick with our notation for solid dots and open dots, and we will show our decreasing function, um, or we are decreasing from -2 to -1. I honestly don't think it matters because all you're doing as far as the parentheses, because really all you're doing is establishing a starting point and an end point. But it's okay to write it like this. So we go downhill, and that's decreasing. And then if we look at the other part here, we are decreasing again from +1 to +2. So 1 to 2. And we have an open dot at 1, so I'm going to go ahead and put parentheses. And we have a solid dot at 2, so I will put a bracket. So we put -2 to 1 and 1 comma 2. All right, so that's increasing and decreasing, looking at our graph. Example number 2, the average rate of change of a function between the indicated values of the variable. So looking at this graph, I have 1 comma 4 for my first point and 5 comma 2. Now, since we're looking at a graph, I can just know that average rate of change is just like slope. So I have ordered pairs, so why not just use our slope formula? Y2 minus y1, x2 minus x1. So we will identify x1 and y1, x2 and y2. So y2 is 2 minus y1, which is 4. So 2 minus 4. And then x2, which is 5 minus x1, which is 1. So 5 minus 1. So 2 minus 4 is -2. 5 minus 1 is 4. And I always reduce fractions no matter what and where I am using them. And it would be -1/2. And that would be my average rate of change. So average rate of change equals -1/2. And that's just represented between those 2 points. So, if we're talking about some kind of sales, we have decreased our sales from, let's say this is day 1 and day 5. We have decreased our sales from day 1 to day 5 by an average of 1/2 unit. So decreasing because we are obviously negative. So that's kind of why you would use average rate of change regardless of what the curve is showing you. Okay, now let's look at this third example. And we have determine the average rate of change of the function between the given values of the variable. Now, because this is a function, we are going to establish A and B, and we are going to have f of b minus f of a over b minus a. And so to find f of b, we plug in f of 0. So the fact that b equals 0 and a equals -2, as I have established here, you can switch them if you want, but just know that you would have different values or different numbers to be plugging in at the times I would. Anyway, if I establish b to be 0, so b equals 0, then f of 0, so f of b, is 1 minus 3 times 0 squared. Well, 0 squared is 0, times 3 is 0, 1 minus 0 equals 1. So f of 0, so we have 0 and f of 0. So b is 0, f of b was 1, right? So we took b, plugged it in, got it. So that would be our values for f of b and b. So now for a is -2. And when I find f of -2, I have 1 minus 3 times -2 squared. -2 squared is 4, and 4 times 3 is 12. So 1 minus 12, that's -11. So a is -2, and f of a ended up being -11. So now I'm going to plug into the formula for average rate of change. So I'm going to give myself some space here. All right. And we already have our values from b and f of b. And we have our values of a and f of a. All right. So f of b, which is 1, minus f of a, which is -11, over b, which is 0, minus a, which is -2. So 1 plus 11 is 12, 0 plus 2 is 2, and 12 over 2 is 6. So our average rate of change is 6. All right. So it's just a matter of keeping it straight. It's not too difficult. It's just knowing that formula and keeping it straight when you plug the numbers in and keeping track of it all. Okay. And that's it for 3.3.